today we are going to solve LeetCode problem number 3, that is longest substring without repeating characters. So we are given a string S. Find the length of the longest substring without duplicate characters. For example, this is our string S containing the character A, B, C, A, B, C, B, B. So we have to find a longest substring such that it does not contain any duplicate characters, and without having duplicate characters, which we have to without having duplicate characters, it should be maximum among all the substring which can be possible without a duplicate character. So this is our string. So what can be a substring? A B C, A B C A, A B C B. This can be substring. Then from B, if we check substring, then it can be B C A, B C A B. From B, if we check BC is substring, BCAB substring, BCAB is substring. So one intuition can be take substring from each character. Means from A, take the substring and check A, then check for B, A, B, A, B, C. If we find a duplicate, then we will return. So for every character, one intuition can be for every character we will check. For A, we will check the substring A, B, A, B, C. So and update the maximum length. Maximum length is now 3. Then if we will counter A, then just if we encounter A, then move to the next pointer, that is B. Then for again B, we will check again for B, we will check all the substring, that is B, C, B, C, A. And if we encounter another duplicate variable, that is B, then we will simply break the loop. Then we will check for C. So for each character, we will have to check for all the substrings. So the time complexity will go to big of n square. So that is not optimal. So to optimize this, we will use sliding window pattern. For this, we will take two pointer left and right and initialize with 0. And for expansion, we will use a right pointer, and for contraction, we will use a left pointer. So every time we found something unique, we will just add it to the set and move our right pointer ahead. And every time we right counter encounters a duplicate, then we will move the left pointer to shrink the window size. After shrinking, and again shrinking, if after shrinking, if we found if it's longest substring, then we can return. So to increase the window size, we'll use right, and to shrink the window size, we'll use the left. So now let's go to understand. We'll declare a two pointer left initialize with 0 and right, and also initialize it with 0. Then we will take a variable maxi in which we will store the maximum substring length. Then we will declare a unordered set of type character. So every time we'll expand our right until it goes to the length of the string. So while our right is less than s dot size, then we can do. Okay. So right is less than s dot size, then we can move ahead. So every time in set we'll check if so we'll use right pointer to increase the window size, and we will use left pointer to shrink the window size. So right pointer would move ahead, right pointer would move ahead, and left pointer would move from the backward. So right pointer is moving ahead and if it's checking if A is already in set or not. If A is not in the set, then simply add A to the set and move the right pointer ahead. So right is currently 0. We will check if set dot count s of right. We'll check if this not exists, then simply insert in the set s dot insert insert s of right. Then we will move the right. We will move the right pointer ahead. We'll check if set does not contain the right. We'll insert in the set. We'll move the right pointer ahead. If we found that set already contains set A, then it's not good. We will remove it from the left and move our left pointer ahead. Set dot erase s of left. Move our left pointer ahead. At last, we'll compute the maximum as maxi, and will be the maximum the index number, that is right minus left. Denoting right minus left as plus 1, we can simply do right minus left as I will tell you ahead. By doing right minus left, as we in right we are already one step ahead. For 0 our right is 1, for 1 our right is 2, for 2 our right is 3. So we can directly do right minus left, and at last we can return our maxi. So now let's try to run and check for all the three test cases. So we got a error, we have not used semicolon here. Now let's compile and check all the three test cases. So the three test cases are passed. Now let's submit and check for all the test cases. So all the test cases are passed. Now let's discuss the space and time complexity. So space complexity is we are running from all the elements big of n, it and we have not used any inner loop. So space time complexity is big of n.